Hi, Pre-Calc. Miss Lois here, going to teach you Unit 6, Day 1, Pythagorean Identities. You've already learned some identities, so we're going to add on to them. You're like, wait, what identities did we learn? Well, guess what? I'm going to go over the ones you have learned that you didn't realize you learned. So these are called our reciprocal identities. So sine theta equals 1 over cosecant. If I can spell. Cosecant theta. So cosine theta equals 1 over secant theta. Tangent theta equals 1 over cotangent theta. And then we have, of course, that cosecant theta is the same thing as 1 over sine, anytime I see that. Secant theta is 1 over cosine. And then cotangent is 1 over tangent. Now, tangent and cotangent have two other identities that we're going to talk about. So tangent can also be the same thing as sine theta divided by cosine theta. So that's an identity. And then since cotangent is the reciprocal of tangent, then it's also the reciprocal of sine over cosine. So it's cosine over sine. So those are all the identities you should have already known, we should have already seen. So now that's going to help us create all the other Pythagorean identities. So the Pythagorean identity, the main one that we're going to use, that anytime you have sine squared theta plus cosine squared theta, it is always going to equal 1, the radius of the unit circle. So if I square my sine squared term, so like let's do 1/2 and root 3 over 2. Okay, let's just see if this even works. If I square that sine value and I square root 3 over 2, will it equal 1? Well, if I square 1/2, it's 1/4. Plus, if I square that, it's 3 over 4. And when I add my numerators, 4 over 4 does equal 1. That's our Pythagorean identity. That's the first one. So you need to have this memorized. I'm going to erase that just to show you that it always equals 1. No matter what I pick on the unit circle, it's going to equal 1 when I square the sine value and the cosine value and add them together. All right, so there's 3 Pythagorean identities you need to know. So to get the first one, we're going to take this formula, and this is where it comes from. Because sine and cosine is not the only thing on the unit circle. We got to have secant, cosecant, all that stuff. So to get one other formula, we can divide everything by sine squared. And if I were to clean this up, so sine divided by sine is 1, right? Cosine squared divided by sine squared. So if I look at those top identities, cosine over sine was cotangent. Well, since both are squared on the top and squared on the bottom, that's going to equal cotangent squared when you clean it up, changing the identity. 1 over sine squared, if I look at the top, where is 1 over sine? It's the cosecant one. So 1 over sine squared is going to equal cosecant squared. So that's our second identity of the Pythagorean identities. So now if I take the same identity, so let me erase all of this. You can rewrite the identity to show where it comes from. I'm going to now divide everything by cosine squared to get the last identity of our Pythagorean identities. So now let's do that in the green down here. So sine squared over cosine squared, looking at the top of the identities we already knew, sine over cosine is tangent. And again, since they're both squared, that's going to be tangent squared. There's not going to be an instance where it's not both squared. We're cleaning this up. We're just since I'm dividing everything about by cosine, it's not changing anything about the formula except the identities. All right, so then cosine squared divided by cosine squared is 1. 1 over cosine, looking at those top identities, 1 over cosine is secant. And again, since cosine is squared in that formula, secant is going to be squared. And that is our last. So the 3 Pythagorean identities, erase that we got going on there. The 3 Pythagorean identities are this, and this. So I'm not a person who's good at memorizing, but I can remember that sine squared plus cosine squared always equals 1. I just remember that. And then to get the other 2, I just got to clean it up because I know the top identities. You gotta start somewhere. Either memorize these or memorize the easy ones and clean them up and derive them. Okay, so now we are going to jump into examples on how we're going to use the Pythagorean identities to solve things. So I'm going to scroll up because I don't need that top anymore because I'm going to use these identities right here. And we're going to do only 2 examples and then we'll be done with this video. So here is the first example. It wants me to find secant theta and tangent theta if sine theta equals -2 over 3 and tangent theta is greater than 0. We've already done problems like these. You can make a triangle. That's one way to do it. But we're going to teach you another way to do this because maybe this is your preferred method. This is all about what is your preferred method on how to solve something in trig. Okay, so we can use an identity. So the identity from the 3 that I'm going to use is the sine squared plus cosine squared equals 1 because they gave me sine. Whatever they give me is going to determine the identity I need to use. I'm not going to use, tangent and secant, but I don't know tangent and secant, so I wouldn't have anything to plug in to the tangent and secant identity. So I need to use the sine squared plus cosine squared because I know sine and I can plug it in so that I can find cosine. And then cosine can help me find secant and it can help me find tangent. So also we need to determine where our quadrant we're in so that we know who's positive and who's negative, no matter what. If you're doing a triangle or not a triangle, you're always going to have to do that. So the quadrants, since sine is negative, that means it can only be the bottom 2 quadrants. But since tangent is greater than 0, that means it's positive. That right there tells me that I am in the 3rd quadrant because tangent is only positive in the 1st and 3rd quadrants. So that's where I'm going to be able to figure out if secant is positive or negative or tangent is positive or negative. Well, we know tangent is positive. So let's plug in. So here's my identity, sine squared theta plus cosine squared theta equals 1. So I'm going to plug in what I know. Sine is -2 over 3, and I'm going to square it, plus cosine squared theta equals 1. So we're going to figure out what cosine is. So this gives me 4 over 9 plus cosine squared theta equals 1. So then I'm going to subtract over 4/9. Subtract over 4/9 because I'm solving for cosine. Why am I solving for cosine? If they don't ask, I can't find tangent or secant without cosine. So then 1 minus 4/9. So 1 is the same thing as 9 over 9. So I could subtract my fractions. 9 over 9 minus 4 over 9 is 5 over 9. And then I'm going to square root. Now, when you square root something, it is a positive or a negative value, plus or minus. Well, we've already determined what quadrant we're in, so it's not plus or minus, it's one or the other. And since I'm in the 3rd quadrant, based on the criteria they restricted me to, it's going to be a negative root 5 over 3, because when you square root something, you can square root the top and the bottom separately to clean it up. So that's cosine. So now we can use that. So let's use that to find secant. Secant is the reciprocal of cosine. And the reciprocal means I flip my fraction of cosine. So secant is then going to be -3 over root 5. but then we have to get rid of the radical in the denominator. So the final answer for secant is negative 3 root 5 over 5. That's that answer. And then the second answer, tangent. Remember, tangent is the same thing as sine divided by cosine. So sine, they told us, is negative 2/3. I'm going to divide that by my cosine that I just found. So negative 5 over root 3. When we divide fractions, we multiply by the reciprocal, or keep, change, flip. If you would like to use my little catchphrases, keep, change, flip. I keep the first fraction, change to a multiplication, and flip the second fraction. Keep, change, flip. So then that means, since now that I've flipped it, I have a 3 on the top and a 3 on the bottom, and that crosses out, or you can multiply straight across to get negative 6 over 3 root 5, and then divide 6 by 3 to still get 2. Okay, so negative 2 over negative root 5. Well, negative divided by negative makes a positive, and then I have to get rid of the radical in the denominator. So the final answer is 2 root 5 over 5. And that is how you use the Pythagorean identities to find the other trig functions based on the information. Again, we could have easily done this as a triangle, but this is another way to do it. Write this equation down, or this problem down, pause the video, write it down. We need to solve this equation, and it's restricted, so we're not finding all solutions. So anytime I'm solving, I need this equal to 0. When I move, so I'm going to move over the tangent. I'm going to add tangent so that my secant is positive, and you'll see why in a second. I want them to be positives, because if you have a squared term, you're going to end up factoring, and the leading coefficient should always be positive when we factor. So secant squared theta plus 2 tangent theta equals 0. When we're factoring, we have to get it equal to 0. Well, factoring, they have nothing in common. Secant and tangent, I can't take out a GCF. This is where the identities come into play. I am going to change secant to be the identity that I wrote up here. So secant squared theta is the same thing as tangent squared theta plus 1. So I can change, since it's an identity and it equals this, I can change that secant to be tangent squared theta plus 1. So I change that whole thing, and then everything else stays. Now, because the goal is to have just one single trig, if you can't take out a GCF, the goal is to change it so that I only have one trig function into play. Now I'm going to put this in order so that I can factor. Tangent squared theta plus 2 tangent theta plus 1 equals 0. Now it looks like a quadratic. Like, remember, you can change these to look as x squared plus 2x plus 1 equals 0, and I can factor it. So it would be x plus 1 equals 0. Therefore, x has to equal negative 1. Now we got to put tangent back into play, and so tangent theta equals negative 1. And since I'm restricted to a unit circle, I need to get my unit circle and figure out when tangent equals negative 1. Well, tangent is only 1 when it's the same thing divided by the same thing. So all the pi over 4s. So to make it negative 1, it would be quadrant 2's pi over 4 and quadrant 4's pi over 4. So 3 pi over 4 and 7 pi over 4 is when tangent, so my theta is 3 pi over 4 and 7 pi over 4. We have now made this equation solvable by using our identities. And that is what you will be practicing in class. It has been a pleasure, my friends, and I will catch you later. Bye.